All right, so in this video, we are going to solve a couple of quadratic trigonometric expressions. So here's the first one. It's already factored for us. So now that my two solutions over here, cos alpha is going to equal to +1, and here sine alpha equals -1. If I want to solve these, I know I have to use my cos and sine graph. Cos graph just looks like this. And my solutions between 0 and 2 pi, where cos alpha is 1, are just 0 and 2 pi, these 2 points here. So alpha equals to 0 or alpha equals to 2 pi. Then for a sine graph, the sine graph looks like this. -1 is down here, that's 2 pi. So sine alpha is -1 at 3 pi over 2. And these are my three solutions for this question. Let's try the second question. Two sine beta plus 1, 2 cos beta plus 3 equals 0. So again, this one is in factored form. I can just start by splitting my two brackets. So we have sine beta equals -1 divided by 2, and over here cos beta equals -3 over 2. Now all I have to do is my cast rule for each one. Sine is negative in my bottom two quadrants, in these two. I'll do the sine inverse of -1 over 2 in my calculator, and I'll get pi over 6 as my acute angle. So my two solutions for beta over here are pi plus pi over 6, which is 7 pi over 6. And over here, it's 2 pi minus pi over 6, which is 11 pi over 6. Cos is negative in these two quadrants. I'll do the cos inverse of -3 over 2 in my calculator. And I get basically no solution, because you can't cos inverse a number that's greater than 1 or less than -1. This one just has no solution. So for this question, I only have two solutions. Let's try the next question, which is tan alpha plus tan square alpha equals 0. So this is no longer factored. I need to factor this question. So to factor this question, I will common factor out a tan alpha. I'm left with 1 plus tan alpha. So I can split this now. So tan alpha equals to 0, or 1 plus tan alpha equals 0. And then for tan alpha equals to 0, you want to use a tan graph. This is a tan graph between 0 and 2 pi. This pi, so tan alpha is 0 at 0 pi and 2 pi. So alpha equals to 0, pi, and 2 pi. Over here, I'll isolate my tan alpha. So tan alpha equals -1. I'll use my cast rule here now. So tan is negative in these two quadrants. And now I'll do the tan inverse of -1, which is basically giving me an acute angle of pi over 4. So my first solution is pi minus pi over 4, which is 3 pi over 4. My second solution is 2 pi minus pi over 4, which is 7 pi over 4. So in this question, I have 5 solutions in total. Let's go to the fourth question. The fourth question is a trinomial. Two cos square t plus 3 cos t plus 1 equals 0. So I'm just going to write this as a regular trinomial on the side. I'll replace my cos t's with x's. So this is the same as 2x squared plus 3x plus 1 equals 0. I'll solve this with my man. So multiplies to 2, adds to 3. It's a complex trinomial, so I'll start with my fractions. And then my numbers are 2 and 1. I can simplify this one to x over 1. My factors here are x plus 1 and 2x plus 1. So I come back here and I write it. It's basically, instead of x, it's cos t plus 1 and 2 cos t plus 1. So now I can solve this. Cos t equals negative 1. Cos t equals negative 1 over 2. I'll use my graph for this one. Cos of t is negative 1 at basically pi. I know t equals to pi for this solution. And then for this one here, I'll use my cos rule. Cos is negative in these two quadrants. We'll do the cos inverse of negative 1 over 2. And I get an obtuse angle in the calculator. So my first solution for t is 2 pi over 3. My acute angle here is pi minus 2 pi over 3, which is just pi over 3. So this one is also pi over 3. And my second solution is going to be pi plus pi over 3, which is just 4 pi 3. So in this question, I have 1, 2, 3 solutions. And then let's do one last question. 4 sine squared tan x minus tan x equals 0. So in this one, the first thing I have to do is I have to common factor. Let me common factor here. I can common factor out of tan x, and I'm left with 4 sine square. Oops, my x is missing there. X minus 1 equals 0. Now you can factor this further, or you can just solve it. I prefer to solve because sometimes you can't actually factor and you'll have to solve. So I'll just stick with solving. 4 sine square x minus 1 equals to 0. So 4 sine square x equals 1. Sine square x equals to 1 over 4. If I square root both sides to get rid of the sine square, I'll have sine x equals to 1 over 2, or sine x equals negative 1 over 2. Remember, when you square root, you'll always have two solutions. So I have 3 equations to solve here. My tan graph, for my tan equation, it's 0, so I'll use a tan graph. And I did this one a bit earlier, so I'll do it a bit quick. My 3 zeros are 0, pi, and 2 pi. My first 3 solutions are 0, pi, and 2 pi. These two I'll solve using my cos rule. Sine is positive in these two quadrants. The sine inverse of 1 over 2 is just pi over 6. So my first solution here will just be pi over 6, and my second solution will be pi minus pi over 6, which is 5 pi over 6. Let's come to this one last. I'm going to do my cast rule here again. Sine is negative in these two quadrants. This is sine inverse of negative 1 over 2. I get the acute angle as pi over 6. So my first solution here is pi plus pi over 6, which is 7 pi over 6. The next one is 2 pi minus pi over 6, which is 11 pi over 6. In this case, I have 1, 2, 3, 4, 5, 6, 7 solutions.